As we wrap up the conic section chapter, chapter 10, I have a joke for you. I don't think I've told you this joke yet. All right, I have a joke. Here you go. What do baby parabolas like to drink? Hmm. Do you know? Quadratic formula. I kill myself sometimes. No, that wasn't very funny. I know. All right, anyway, 10-6 translating conic sections. So we're going to begin with an ellipse that's been translated maybe to the left or to the right, maybe up or down. Before we can get a feel for how this ellipse has been translated or transformed from the origin, what we're going to do is make a really quick rough sketch. So here we go. I'm going to put my vertices for this ellipse at -5, 1, 1, 2, 3, 4, 5, up 1. This is a vertex. And then over 1, up 1. Here's my other vertex. I also am going to have a focus at -3, 1. So there's a focus. And what I know about ellipses is that they look something like that. And that is a really badly drawn ellipse, but you get the general idea. My focus is somewhere here between the vertices. Now, before I go any further, let's kind of see if we can kind of pinpoint where the center of this ellipse is. So I've got this horizontal distance of 6. There are 6 jumps between 1 and -5. And if I split the difference of 6, that would be 3. So I'm just going to count my way in 3. So 1, 2, 3. This is going to be my center point, and that center point is at -2, 1. Okay, so I'm on my way then to writing the equation of this. So with an ellipse, we're going to have an x squared plus a y squared, and then we're going to set it equal to 1. Now, I went to the left 2, so I'm going to write x plus 2, and I went up 1, so I'm going to do -1. Remember that if I look at those as zeros, that would be x equals -2, and y is equal to 1. Okay, then underneath the x, I need to put half the length of the major axis. This is my major axis, and there are 3 units right here. So this is going to be 3 squared. And then I also need to include half the length of the minor axis. And I don't really know I don't know what this is. This is going to be b, and I don't know what kind of a vertical distance I'm looking at there on my ellipse. What I do know is the relationship between A, B, and C. So to find B, I'm going to remember that C squared is equal to A squared minus B squared. Look back at your notes for 10.4. Now, C is going to be the distance from the center to the focus. There's only 1 unit between the center and the focus. See there, 1 space. A squared would be 3 squared, and then I don't know what B squared is. So let's solve this. 1 is equal to 9 minus B squared. I'm solving. I'm going to divide both sides by 1. I'm going to square root, and I'm going to square root. So B is equal to the square root of 8. Now, that was kind of a pointless exercise because b squared will just be 8, so I can just put an 8 there. Maybe I want to change this 3 squared to a 9. Okay, there we go. We have a translated ellipse. It's translated because the center is no longer the origin, 0, 0. Instead, we had to shift it to the left and up. All right, now in this next section, I'm going to throw a whole bunch of general form equations at you, and you have to identify the conic section. So let's take a minute and write down 3 examples. Letter A, x squared minus 8x minus y plus 19 is equal to 0. B, 3x squared plus 6x plus y squared minus 6y is equal to -3. And then the last equation is x squared minus 4y squared minus 2x minus 8y is equal to 7. So what we need to be able to do is identify these as circles or parabolas or ellipses or hyperbolas. These are all general form. We call this general form. And we are used to recognizing them from their standard form. Like that equation we wrote in example 1, that was a standard form because we can really clearly see the center and then the lengths of the major and the minor axes. Okay, so as I look at letter A though, I recognize right off the bat that this is going to be a parabola. How do I know that it's a parabola? I know that it's a parabola because I see one y and then I see the x squared term. I don't have a y squared term. So this is going to be something along the lines of y equals x squared, blah, blah, blah. Maybe it's going to open up or down. I don't know if it's going to go open up or if it's going to open down. I just know that it's going to be a parabola. I'd have to do a lot more work to it to determine how it's going to open. But I need to be able to recognize that it's a parabola. Now the second equation, what do we have here? Well, this time I have 3x squared and a y squared, so I know that this one is going to be an ellipse. I know it's going to be an ellipse because you know, something x squared plus something y squared, hopefully eventually I can get it equal to 1, put something under here, put something under here. That's going to be an ellipse. And then finally, letter C. What's going on here? Well, what I recognize is x squared and then a negative y squared. So if you have x squared and a negative y squared, what is that? Did you say hyperbola? Yep, it's a hyperbola. Whenever you have a negative y squared, that means it's been filleted open, and I can even go as far as saying this is going to be a parabola that opens to the left and to the right, or hyperbola that opens to the left and to the right because the x squared term is positive. So the next time we get together, we're going to begin with, I don't know, I think I've got 8 or 10 of these general form equations, and you're just going to have to do a little detective work and tell me what the actual conic section is. That's a really good analytical tool for you to have in your tool belt as you enter maybe a analytic geometry class. All right, good work. See you tomorrow.